Now let's look at some tests of grounding equipment that were conducted at the A.B. Chance Research Center in Centralia, Missouri. Now let's look at some tests of grounding equipment that were conducted at the A.B. Chance Research Center in Centralia, Missouri. In each of these tests, we use essentially the same equipment: a 40,000 amp duck-bill ground clamp and 4/0 copper cable. In the first test, using 15-inch phase spacing, we use a configuration consisting of 3 long leads coming from the duck-bill clamp down to a common ground connection. Bear in mind that this is slow motion photography. That initial cable movement probably occurred in a fraction of a second. Continuing with 15-inch spacing, but changing the configuration now to a phase-to-phase jump ring with 1 lead down to the ground connection, we'll pulse this configuration with 11,000 amps. There you see a very dramatic difference in cable motion, emphasizing the need to minimize the cable slack. In this test, we continue with 15-inch phase spacing. We go back to our original configuration of 3 long leads coming down to a ground connection, pulsing at 18,000 amps. You can see that that would represent a serious hazard to a lineman working near that ground set. We go back now to our phase-to-phase jump ring method, using 1 lead down to a common ground. Continuing at 15-inch spacing, we pulse now with 20,000 amps. Continuing the phase-to-phase jump ring method and 15-inch spacing, we're up now to 40,000 amps. You'll like this test. What we succeeded in doing here was generating a phase-to-phase fault. We took a little break in the filming here, and our cameraman went and changed his underwear. To save wear and tear on his nervous system, we went to 36-inch phase spacing, pulsing at 20,000 amps, using a configuration of 3 long leads down to a common ground. Note the tremendous cable movement. Continuing at 20,000 amps and at 36-inch spacing, we change our configuration to phase-to-phase jump ring. However, notice the long drooping leads, and note how high they jump when they're pulsed with a fault current. That would be a serious hazard to any man working near that. Continuing at 20,000 amps, using the same phase-to-phase jump ring configuration, we shorten the leads. Even though we get essentially the same amount of motion, by shortening the leads, it would be more difficult for those leads to make contact with a man working near that area. Moving up now to 30,000 amps and continuing at 36-inch spacing, using the configuration of 3 down leads to a common connection. Continuing at 30,000 amps, changing to the phase-to-phase jump ring configuration. Note how high those cables jump. Continuing at 30,000 amps, continuing with the phase-to-phase jump ring method, but shortening the cables. Moving up to 40,000 amps and continuing at 36-inch spacing, using the configuration of 3 long down leads. Note the clamp on the far left. That clamp was deliberately left untightened to illustrate what can happen when ground sets are improperly applied. Continuing at 40,000 amps and 36-inch spacing, using the phase-to-phase jump ring method. Continuing again at 40,000 amps, 36-inch spacing, phase-to-phase jump ring with the cable shortened. You will now see a series of tests using the 8-foot T-handle temporary driven ground rod. In these tests, you will note an incredibly long duration time. At the conclusion of the film, I'll explain that. In the first test, we put the rod in the ground 1 foot. We had a rod to station resistance of 5 ohms, pulsing with a fault current of 2650 amps for a duration time of 53 cycles. In the second test, we again put the rod in the ground 1 foot with a rod to station resistance of 26.5 ohms, pulsing with a fault current of 4630 amps for a duration time of 123 cycles. Bear in mind that these tests were done in central Missouri in the dead of winter. In the third test, we put the rod in the ground 6 feet with a rod to station resistance of 17 ohms, pulsing with a fault current of 3450 amps, again for 123 cycles. There's ignition, and we have liftoff. In the final test, we used 2 rods in parallel. We put the rods in the ground 6 feet with a total rod to station resistance of 9 ohms, pulsing with a fault current of 4320 amps for a duration time of 61 cycles. We normally conduct these tests just before we go fishing. It gets all the worms out of the ground. Now let me explain something about those long duration times that you saw in the ground rod test. By using a long duration time coupled with a low fault current, we were able to simulate what would actually occur with a much higher fault current and a much shorter duration time. The AB Chance Company earnestly recommends, whenever using a temporary driven ground rod, place it as far as possible from the work area and barricade it. Protect both yourself and your public.